Hey guys, welcome back to my YouTube channel, Numa the Engine. And today we are going to be discussing about real-time data engineering processing. So we're going to focus on few things, whereby we look at what real-time data engineering means in respect to also micro batch processing and stream processing. And we'll look at an example of a real-time data engineering processing situation. So let's get right into it. Um, and if you have not liked and subscribed, please do now. Thank you. All right. So what do we look? Let me start from micro batch processing. So suppose you have different data sources, whereby the data source can be an API, a database. It can be a raw file, right? So, or it can be an analytic platform like Amplitude or Google Analytics. So, suppose you are getting data from there and the data you want. So, the purpose of the data is an important thing. The purpose and the use of the data. So, this is where we come about understand what the stakeholders want, understand the business requirement of why you need that data. So based on understanding the business requirement of why you need the data, this is going to help you in making a decision of what process to use, right? Is it a ETL process or ELT process? Do you want to do a batch processing, or you want to do a streaming processing, or do you want to do a real-time processing or a micro batch processing? So suppose you want the data to come at a particular period of time. When I mean particular period of time is how fast you want the data. The delivery of the data is so important. So when we talk about delivery of the data is when is the data coming, throughput, we're looking at latency, we're looking at other things related to that area. So what suppose your business manager or stakeholder says, I data engineer A, I want you to give me a real-time analytics on our user activities. This is the moment for you to think. Let's say, okay, user activities, how fast do they want the user activities? Do they want to use the user activities for prediction? Do they want to use the user activities to make informed decisions for any project or for any marketing scheme, right? So you are going to determine, what do I want this so for micro batch processing, you have to take it in the face of the data you are collecting will appear in small batches, right? They will appear in small batches. When I mean small batches, it appears in small batches at short intervals. So let's say you are getting data from let's say you are getting data from, right, Amazon Web Store. So you want to get an information from Amazon Web Store. So the information I want to get from Amazon Web Store is who is buying, how much are they buying, how are they buying, right? Are they buying through card, PM, or how is the user activity occurring? So you want to send that data right to your system, your microbatch system. In your microbatch system, the system can be basically a ETL process or a ELT process, right? And let's say you are going to use something like Apache Spark structure streaming, right? To just process the data in microbatches at a particular interval. So you want to be processing that data every and let's say you want to use an in window, you want to process the data every 2 minutes or every 5 seconds, right? That's how you process the data. This is how like data you can process at short intervals, like every 5 seconds. Get me the data from Amazon Web Store and do the analytics. Simple like that. So it can just be a periodic ingestion. The data ingestion is periodic, right? Periodic data ingestion. That's basically the idea of it. So for micro batch system, it's like a periodic data ingestion scenario. So let's see, why would you want to use micro batch? Maybe you want easier scalability, easier fault tolerance, right? And also you just want something that is just good enough. You don't want to overload your system. You know the strengths and you know why you know the real time you need is something that just happened at a particular period of time, right? There's this mistake we make, that the real time should be instantaneous for some kind of particular analytics, but that cannot be so. So which will bring me to real time um real time processing. So let's say real time processing. So if you want to work with real time processing, right? Let me remove this. Real time processing basically is you working in a system whereby the data is happen as soon as it's generated, it is received. So let me give you an example of as soon as generated it is received. It's basically you are saying you want to do a fraud detection system. Suppose you are looking at an ATM system to detect if somebody is using somebody's credit card or debit card in a wrong form, or somebody is trying to get to your house and you can alert the police immediately. So these are like the systems you use real time data processing, or a stock trading system whereby you want to be executing trade on live market data, like response to um when you have a low entry point and you have something like or stop loss or low entry point, or when to get out of a trade. Exactly, something like that. Or self-driving cars, like safety self-driving cars that you have in something like in a Tesla, right? In a Tesla, in a Model S or something. So it's just for immediate decision making. If your business wants immediate decision making based on real-time data, right? Based on from the data source or from wherever the information is come from, the ingestion, you have to use a real-time processing. And streaming basically is like is like a continuous integration. So let me remove this and put streaming processing. So for streaming processing, basically it's like a continuous integration ingestion processing, whereby as the data is coming in, everything is in motion. So I'll look at this in the form of YouTube streaming, right? YouTube streaming, like YouTube streaming, you are streaming, let's say you are streaming with an OBS studio. Whatever you are doing is happening at real time. It's happening like live comment feed on your Twitch stream, right? Or a social media chat, or IoT devices, or something. Sometimes it can be defense systems, right? Defense systems like Anduril, or something like Palantir might use, right? So it's just like an ongoing data flow, and low latency pipeline for is like low latency pipeline is like what they are going for. So what are the differences between all these three? So if you are looking for something at particular interval, you go for micro batching, short interval micro batching. If you are looking for something for event by event, as it's happening, it is showing, you go for real time. And if you are looking for something that is continuous, you go for streaming. Streaming, something that's continuous, that is like a live field, you go for streaming, right? And I'll say this also, that complexity in terms of this is basically, it depends, right? It depends on what you are using. So I would say the complexity here is not that hard, right? Complexity here will be kind of crazy here for real time, right? Complexity here will be, let's just say, put it as between, it's also hard. It's like high complexity. So what kind of tools can you use here in micro batch? Micro batch, you can use tools like Spark structured streaming, which I use for a project whereby I used it for an NGX project. So the NGX project was basically streaming, right? NGX project was basically streaming information about from Nigeria Stock Exchange website, NGX streaming. I just called it NGX streaming. I just had to use streaming because that would sound cool. So NGX streaming, I basically stream data from the Nigeria Stock Exchange website. Every information, every trade that is happening. So every trade that happens on the website happens every 5 minutes. That's when they update the information. That means that it is happening at a micro batch way, right? Every information is happening at a micro batch way at that website. So my goal was to stream every 5 minutes, stream the information based on market time. So if market is starting by 9 p.m., 9 a.m. rather, if market starting by 9 a.m., check the trade every 5 minutes, give me information about the trade. So basically that's like the system I use micro batch for a project like that. So I was just ingesting data based on that situation, and I use Spark structured streaming for my engineering purpose, right? Engineering processing rather. So real-time processing, yeah, these are like system. There are different tools also that works. Like I don't know if you've heard of Byteworks. Byteworks works. Apache Flink, Apache Storm are also like things you use for systems like this. Let's say in this kind of thing, I did it for a project whereby I used I don't I want to remember the project. Okay, for a ride sharing app, right? A ride sharing app. I used basically um I use basically real-time processing here. So I've not really done a streaming processing before because it's a continuous stream. But if I want to choose a project based on this situation, if I want to choose a project based on this, I'll say perhaps a defense system whereby maybe we are targeting or a live chat feed for a YouTube channel, right? Live chat feed of YouTube channel to like predict some things, etc. I can use uh, this streaming processing live chat feed. So if you want an example of that, there's a YouTuber I love watching. It's called the Prime Agent. I love his videos, so subscribe to him also. So okay, so or censored so let's jump right to a project whereby I use real-time processing. So this was I promised this, but before I jump into that, when I was trying to do this project of of a ride sharing app, I first of all did some research. Right, the research what I did was look at an existing real-time data infrastructure at Uber. So reading this paper really guided me on what I was going to do and expect. So basically, I just used what they did. So they get the data from the source, their real-time data infra, and the data consumers. That means that the end users of this real-time data infra. So basically, it goes in the line of okay, it goes in the life of Kafka, Flink, OLAP like Apache Pinot, Apache Presto for your SQL, and your dashboard or whatever you want to use that as the end user face, right? It's the same thing we have in this scenario because I had to do research on what I wanted. So it's just like literally the same thing. Yeah, so we Apache Flink. So based on that, so I'm just gonna jump right into how I went about my project. So let's go. So basically I use Airflow, Spark. So where I use structured streaming, I use structured streaming for a microbatch system, right? So basically, it was a combination of microbatch and real time. The real time came for Apache Pinot to look at real time information of ride events, while the structured streaming works for scenarios of looking at um, the ride, um, all the whole assessment of all the ride. Like, was the ride cancelled? Was the ride ordered? Was the ride completed? etc. So this was where I used Spark and Spark structured streaming, while real time data was for the event that was happening at real time of who is the rider, when was it placed, what was the start time, what was the end time, etc. are happening in this scenario whereby I used Kafka, Apache Pinot, and Apache Superset for for my analysis. Then structured streaming, I used Spark and I dropped it to my Delta Lake. I use an open table format. So Airflow was just my orchestrator throughout this project. So that was how we went through for this project. And the my I don't want to say this is self-explanatory, but my data comprises of all the services I needed for to do these projects, right? So it was a local setup, so not a pod setup, it was a local setup kind of project, and right, so that's how I went about it. For me to do this project, I didn't have the real-time data per se. So what I did was to generate data for this case. So to generate data for this case, I had to go through a channel whereby I created the data I wanted. So in this folder called streams, whereby I just generated data I needed for the scenario. So I defined the cities, the right types, and the data classes I used were in this format, right? And the right generator is basically the class whereby I generate the right, then converting it to Avo schema. Well, for this case, I tried to use Avo and JSON right? But I set it at JSON later because of some difficulties I faced with Arvo and dependency issues with my Spark, right? So but it worked perfectly with Arvo to my um to Apache Pinot. I had to just use a particular setup for Apache Pinot with Arvo, but with Spark, I don't know what was going on at that moment, but I believe it works with Arvo, of course. This is just my Kafka. I'm generating results from my Kafka. If you can see here, the Kafka producer, and then generate, then close the producer. Basically, so this was where I used the structure streaming. So this area was generate, write requested, write accepted, etc. Then take it to the structure streaming, then take it to my Delta table, right? So the consumer, right? You have to read the messages, and this was where I used JSON. So this was where I preferred using JSON because I was having difficulties with Avo, like I said before. So cool. My tags are pretty much explainable. They are in bronze. So Kafka produced the Kafka, basically streams, right? So I use the Python operator for this purpose, which worked well. You can use a batch operator as long as it works for you. Then Spark Solve. This was where I used the structure streaming. Basically, I also use a bash. I use the bash operator in this area whereby I just had to run Kafka to delta.py. And in Kafka to delta.py, you have basically what I needed to solve that situation. So Apache should I do a tutorial on Apache Pinot? So basically define your schema, right? Define your schema for your Apache Peanuts, then define your tables, right? When you define your tables, you can just work directly with it. Then just set your configuration on your Apache Peanut, and you're good to go. When you set up your configuration, you're good to go. So this basically how I set my configuration: add schema, add table, setup completed. Perfect. So okay, superset config. I didn't really do much here, but it's just a basic setup for superset, Apache superset, right? So um that's all for today now. Thank you for watching, and peace.